Students create aircraft concepts and then they actually fly them in a high fidelity simulator.
Almost like, getting your test paper back at the end of an exam.
For me, I think aerodynamics becomes something that students can feel, and it's not just a calculation.
Welcome into the Future in Flight podcast, coming to you from a hangar somewhere near the flight line, where we've got a little bit more sunshine peeking through the clouds every day and the springtime birds are coming back. What if you could design an aircraft, see it fly, and get feedback from a professional test pilot? That's not science fiction. That's It Flies from ST Engineering Antycip. Today, we're talking with Amir, Kosh, and Gordon McClymont about a competition that's completely reimagining how we train aerospace engineers. Instead of building foam and balsa wood models, students create aircraft concepts and fly them in high-fidelity, physics-based simulators, the same ones used in real aerospace development. Then, actual test pilots evaluate their designs just like they would in the industry. It's the design-build-fly cycle compressed into a day of learning, iteration, and discovery. From 6th-generation fighters to 8 relief drones, from Dayton to Swansea, this is where theory becomes motion and equations become experience. So grab your flight bag and let's explore how simulation is shaping the next generation of aircraft designers. Gentlemen, thank you for joining us today on the Future in Flight podcast.
Thank you, Shawn. Thank you for having us.
Thank you.
Yeah, wonderful. And you're coming to us from way across the other side of the Atlantic Ocean. Tell us a little bit about where you are right now.
Yeah, thanks, Shawn. We're in the UK. So I'm Amir, first of all, Amir Kosh. I'm from Antycip. We are a provider of virtual reality and simulation solutions. So yeah, we're privileged to be here today, and I'm really excited to be on such podcasts. I've never been on one myself, so this is a first for me. Thank you.
Well, we're honored to have you for you first. Gordon, tell us a little about where you're coming from.
Okay, Shawn. My name is Gordon, and I live in the northwest of England, just off the Irish Sea. And I've been up here for 2 years, but spent most of my working life down south and overseas. And so I am retired, so I work for Retired Incorporated. But I do a lot of work with youngsters, with It Flies and other organizations. So I try to give back something that I've got from aviation.
And you have such a great breadth of experience. We're going to talk about some of that and how that plays into the It Flies competition. And Amir, for those who are new to this arena, new to the industry, or maybe haven't heard of the It Flies competition before, tell us a little bit about what that is and how this is different from the standard design, build, fly competitions.
Yeah, absolutely. So It Flies is a design, build, and fly competition, as it's in the name, where students create aircraft concepts and then they actually fly them in a high-fidelity simulator. So it matters because it mirrors real aerospace practices and it helps develop engineers who understand not just the theory, but also the behavior and performance and risks of the concept aircraft that they develop.
Absolutely fun. Totally different. You say a high-fidelity simulator. We're going to get into that a little bit more. What inspired Antycip to create the It Flies program and use these high-fidelity simulators as opposed to more of the traditional paper route?
Yeah, great question. So as we know, simulation is quite important, especially when it comes into aerospace. It's been going on for a very long time, and we obviously understand the importance of simulation and how efficient it can be. So when we decided to look at simulation, it was probably about 30 years ago when our company was formed, and we're a provider of the simulation environments that go into some of these simulators. So there's CGI, the terrain generation. So we have been a proud provider of these kind of technologies for a good 30 years now almost. It Flies actually stemmed from universities wanting to get their students to compete and to work a little bit with their peers together. And the whole purpose of It Flies was not to come up with a whole new competition that does something that is very different to what they study at their course level, but it actually mimics what the course is and what they learn at university level. So students obviously go through aerospace engineering, learning the theories. So It Flies just allows them to bring their theory to life through these simulators. And having these high fidelity simulators, it just allows us to be able to demonstrate and get their students, the student designs to fly. Of course, what makes it really special, the whole It Flies competition, is the fact that we're not just flying the designs, or we're giving it to test pilots to design sort of these flies. And that's what makes it quite unique and special, because students not only are just flying a design that they've developed, but they're given to professionals that know how to evaluate the performance and risks and the behavior of an aircraft.
I can imagine the feeling of these student groups to get to have a test pilot come in. We're going to talk a little bit about that in a minute. But Gordon, why do you think it's so important to have students actually fly their designs and not just calculate them? What is in that transitional that you've seen that really helps this move forward?
Well, I see the whole process as being, for most of engineering projects, be it ships, airplanes, cars, is that you have a design, you have a build, and then you have a use and operate. Between these three groups, you have iterations between design and then building and operating. And actually, engineers, certainly, and pilots, test pilots, are integral parts to these three elements. And what we're doing here is getting their first kind of step between designing something and building something. The build is the simulator that we're going to fly. So we iterate between the operator, the pilot, and the designer, builder, the engineers. So this is really our kind of first meeting, as it were. And that's what we're trying to do here, is introduce them to the end user and the person, the test pilot, who's going to be taking them, working with them through the whole project.
You mentioned a great point, and it kind of mimics what the process is like. Tell us a little bit about how It Flies shows and showcases, kind of mimics that, what real aerospace engineers do, and how they kind of integrate with test pilots to move the project forward.
Yes, exactly. I have worked in commercial companies that actually build airplanes, and we do work with the engineers who are designing everything from the light bulbs and displays to the flight controls, the cockpits, and then all the way through the development of the flight control system, flying it in simulators, and then ultimately we're going to strap into an airplane and go do it for real. And there's lots of issues where we go back from the airplane, back to the build, back to the design, as it were. But, aerospace engineers and test pilots work closely, and there's a phenomenal amount of test pilots who are actually aerospace engineers themselves. They went through college and were aerospace engineers. I'm an engineer. I'm not an aerospace engineer, but I did mechanical engineering, so I've got an understanding of it. There actually is a very close bonding between the aerospace engineer and the test pilot.
It seems like that relationship would be able to make a more complete project, kind of feedback off of each other. And the fact that It Flies incorporates the test pilot really seems to make this more of an end-to-end competition. Now, let's talk a little bit about the student groups and their experience. Gordon, what is it like to see these students experience It Flies for the first time, really from the initial concept and then on to flying, and then having a test pilot actually address and test their design?
Well, you used the word in your question, excite, and it is exciting to be able to see their project that they've designed and coded for the simulator and actually see somebody fly it. And then at the end of the test flight, which is fairly short, is to get the feedback on how it is. And it's almost like, getting your test paper back at the end of an exam. So it is very exciting. I think certainly most of the times I've been on the It Flies competition, it is the first time they've met an end user of their product, a pilot. And I think it is exciting, but it's extremely useful for the students.
Amir, let's talk simulators. Let's talk kind of the real, where the rubber meets the tarmac, as it were. So how early in the design process do students get to start using simulators? And what does that do for them? What does it set in motion for these students?
Yeah, I would say very early, Shawn. Like simulators allow rapid exploration of ideas before teams are emotionally invested into a design. So before you academically or physically maybe start thinking about what solution you want, simulators are really good tools to quickly being able to look at the stability and controls and what the mission of the aircraft is. And those initial iterations can take a long time if wanting to do them on theoretically or on hand. So simulations really advances that stage.
How long are the test flights? I know Gordon mentioned it's kind of a short flight. What are we talking, Amir? How long are these test flights?
Well, typically a test flight can be around 30 minutes roughly, or a little bit less than that. The purpose of the test flight is to go through a few sort of critical points of the flight, and that encompasses of the takeoff, landing, some maneuvers, and focusing on the mission of what the aircraft was built to do. So those performances should give the test pilots a good understanding of how that design performs.
If I may add here is that yes, whilst the test flight in the simulator is 20 to 30 minutes, we get a 20-minute brief from the design team, and that ends up with questions from the test pilot and the engineers to be able to dig deep into the design. And after the flight, we also have a pretty comprehensive debrief section. So end to end, from the description of the project by the team to the debrief at the end, that whole cycle really is the best part of about 60, 70 minutes. So, they get quality time in the competition and in the whole exercise to present, do, and get feedback.
Now, is there the same mission, or do these missions vary for the designs? How do students determine what the mission is for their design, Amir?
Yeah, so we're quite flexible in allowing the students to create their mission profile and what they would like to achieve with the aircraft. As long as the aircraft can be manned and flown, we've even allowed some students to create UAVs as well, because that's been their focus. But as long as we can man the UAV, and then be able to pilot it and be able to control it and take it through the performances for the test pilots, that's the only way that they can evaluate the aircraft. So the limitations are, there's no limitations, quite endless, and we are quite open. And over the years, we have seen some wonderful sort of concepts that are, that do stretch sort of the imagination. Whether a student creates another sort of private business jet, or they create a fighter 6th generation sort of plane. So yeah, there's different types of designs that
Now, we've talked about some of these cool success, these cool designs that you referenced, Amir. Gordon, what types of design mistakes or surprises do you think the simulators help students catch before anything is built, before they come out with these final products?
Well, first thing first is that in real life, design mistakes and surprises do happen, both in the testing the software, the simulator, the build, and even in flight, although we don't like mistakes or surprises in flight. But yes, there are mistakes. Either it's a cross wire or a wrong bit of coding. We've had, for instance, unfortunately, the nose wheel steering, through a misunderstanding, operates the opposite way to the way it actually works in the aeroplane. So it's just like telling a car driver, you steer left to go right. That catches people out. But also, that mistake is a lesson, because that's why we have simulators, to iron out these issues in the safety of a lab rather than in a cockpit or in the air.
Yeah, Amir, kind of follow that up and talk a little bit about how flying a design in a simulator kind of changes the way that students think about aerodynamics and how aircraft actually handle.
Yeah, when I studied aerospace engineering about 10-15 years ago, I think the biggest thing about aerospace is that you can't feel aerodynamics, and it's just an imagination that you have to understand and try to understand, how the lift works, the drag works, how vacuum and suction and all these kind of things that we can't see, whereas you probably see it in mechanical engineering or civil engineering, you just can't see an aero. So for me, I think aerodynamics becomes something that students can feel, and it's not just a calculation, and being able to feel and get a feeling for the lift, drag, and the stability, all of that I think is what the simulation adds.
There really isn't any comparison to lift and drag until you experience them, until you just get a sense of what they are. They're just abstract concepts, and it's great that It Flies is able to incorporate that again into the life cycle of this complete project, and it's amazing to watch this competition take shape and unfold, even as you describe it, just as the project does. Now, Gordon, tell us a little bit about how realistic these simulators are compared to what test pilots or professional engineers use?
Well, this type of simulator would be in the design cycle of an airplane, one of the first simulators that we have that actually flies. Certainly when we design an airplane, and I've been in cockpits that are built with 2x4s, plastic card, and some cardboard just to get the space model of the cockpit. And then the next thing would be maybe doing a desktop fly operation, and then into a simulator like the we have with It Flies, and then into more advanced simulators until we eventually get possibly wrap around full 360 vision or even full motion simulators. So it is part of the cycle. It's about maybe a quarter or a third of the way through the design cycle, but that's where we are. But yes, I have, as a company test pilot, flown in these sort of simulators to do the early evaluation of the flight control system of the aircraft.
So let's talk a little bit about how simulators bridge the gap between theory that we learn in class, the theory that the students are taking in, and then this real-world flight behavior. Amir, you touched on it a little bit with the description of flight characteristics and the principles of aerodynamics. Tell us how these are really tied in, and the students just get to experience that.
Yeah, absolutely. Again, I've been through it. I've experienced half of that, and I've experienced the other half. But seeing students go through that process, right after each other, I think is very fascinating. It effectively turns the equations into motions, and the equations of motion into physical motion. And the performances kind of like go into the experiences and any assumptions that you make, they become evidences. So effectively, anything that we write, any theory that we cover on a university level or academic level, it brings it to life, and that is very important in order to understand how things behave and act. Having the backing of data that you can get those data and run it again with the theoretical data that you've learned, and cross-checking that sort of cycle, then you really have confidence in the way the simulators behave and the way they work, and the fact that you're cross-checking the behavior of the quality of the simulation that you have conducted. Now, it's very important for me to say that it's very important that students use real-time physics-based engine simulators. Obviously, there's gaming simulators out there as well that, although they are really fun and they very visually look very nice to look at, and sometimes they have better flying experiences. But the purpose of those simulators and they're created for entertainment, as it's in the name. Although visually is very pleasing, however, in terms of the physics, in terms of the data, in terms of how it processes that information, it can be incorrect. And sometimes in simulation, we call that word negative training, and negative training can be very it's a no-no for us. It's a very bad thing that if a student picks up a bad habit such early on, then it can be, it can take years and years for that student to forget those habits that they've picked up and those wrong things that they've learned. So in our line of work, we make sure that, in terms of the simulation we offer the high fidelity stuff, and we never do negative training to make sure that the student is bridging the gap and they are taking the theory into simulation without the loss of the quality of what they're trying to achieve.
Amir, absolutely fantastic point. When we talk about simulators, some people just have a concept of maybe, some of these popular gaming simulators, and we're talking, use the words real-time physics-based and high fidelity. So these are different types of simulators than we see on the commercial gaming market, as you just addressed. So that is the real important difference that people know, is that It Flies, the competition, is using these simulators that are just very, very physics-based and similar to what flight is. So when you talk about students experiencing drag and some of the aerodynamic principles, they're allowed to feel them. That's the important thing. Gordon, tell us about an example that you've seen of a student design that looked really great. I mean, this thing it had everything on paper, but it got in the simulator and it behaved a little bit differently. Has there ever been a case where that's happened?
Yes, it has happened. As Amir said earlier on, the students are given free rein on the design that they're going to build. And a lot of the people obviously go for a fighter, an airliner, maybe a aerobatic airplane. But some of them go for quite wacky designs. I say wacky, I mean not quite the norm. For instance, some of them had ideas for aid relief, flying a kind of giant drone piloted and using that for aid relief and other designs as well. So we get the briefing from them at the beginning, what their design idea is and what it's going to do. It looks good on the presentation, but somehow in the simulator, it didn't behave quite as we would expect it to, or what we'd expect to be acceptable behavior. And that's probably because it's maybe a slightly off the piece design, but that's the whole idea, is we've got a great idea, let's do it, put it out there, but it didn't quite work. Maybe they'll come back the following year with an improved version. So yes, some look great, but they don't quite fly properly.
Let's take a quick break from this conversation to tell you about one of our wonderful show supporters. Aviation USA is the leading youth aviation magazine with a mission to attract, educate, and empower youth in aviation, sharing inspiring stories, industry news, and real student journeys from all corners of the flight world. Their Rising Star program spotlights young pilots, mechanics, engineers, and aviation dreamers who are making moves and celebrating their achievements with industry support, gear, and recognition. No matter what your goal, Aviation is a resource, a community, and a launchpad for your aviation dreams. Head to aviationusa.com to subscribe, get involved, or nominate a Rising Star today. And now, back to the conversation. You mentioned design revisions. Amir, about how many revisions do these students go through before they get to their final product?
Yeah, usually several. I would say the first few revisions are probably the revisions where significant design changes are happening, and then through the later revisions down the line, they become more performance tweaks. So yeah, the first simulated flight almost always triggers a lot of ideas and changes. So several at the very least.
Now, you mentioned earlier, you talk about how some of these students get to experience those aerodynamic principles, and they get to work end-to-end with a team. But talk specifically about what skills, name a couple of skills that students develop throughout this competition that you see that kind of directly translate into the aerospace careers.
Yeah, that's, I would say, system thinking, communication. We touched on this, flight behavior. I think that's probably a key one academically. And they understand about how iteration of improvement works in engineering. Iteration is a very important word, I think, in engineering, and just learning that something isn't correct the first time round, and it's always a process, and it's always a loop feedback where you go and you work on a design and you go back and you kind of like feed that information again, or from what you've learned, you feed a new information. So I would say, at least for me, iterations was probably one of the key things that I learned. And you also have to understand that at some point that plateaus as well, and you need to maybe be sensible and stop those iterations if you're not getting any different feedback as well. So being able to work towards a deadline, being able to work with your peers, and understanding when to start or when to act and when to stop, I think that's quite key.
That is a really, really good point, is to be able to say, okay, my design maybe just isn't, or this iteration, whatever that thing is just not cutting it. Gotta move on. Sometimes just stepping sideways allows us to go through the doorway. That is a key lesson right there. So, Gordon, how do you see simulation-based competitions like It Flies shaping the next generation of aircraft designers?
I think the biggest thing I get from it really is that meeting other members of the team, and I mean the team, the aircraft design team, from the software guys who write the flight control stuff, and then meeting the operators, the pilots who do it. So I think that marriage, the first time they get to meet somebody like that, I think is one of the biggest things we get out of the It Flies concept. Also, we do, as we talked about, there is a comprehensive brief that the teams give, and there is a question and answer session at the end of that. So we really dig in and try and find out why they decided to do it that way, or have they thought about this? That's another part of the conversation. So I think that's what they get great value from.
And you mentioned it right in your statement that aircraft, the design, the final product just has so many parts and pieces to go to it. There's so many people that contribute to an aircraft and an aircraft design, that being able to work and learn how to work within these groups and subsegments has got to be just incredibly huge. Tell us about some of the students that have gone on after this competition. Have you kept up with them? Have they given you some feedback on what their experience has been?
Yeah, absolutely. We have. We actually have a few of those students come back for internships to work with us, and so we've seen this work full cycle. And some of these students, move to, they have particular career visions. So coming out the competition, feeling like they've accomplished something, and now that they understand how this work, because for a lot of these students, it's the first time they're actually dabbing into the industry, or getting, like Gordon said, that like design go a full cycle. So for them, it's kind of like getting a bit of a flavor of how maybe a life in the industry might be. So although typically the It Flyers competition, majority of our people who compete, they're typically second year students, but a lot of times we get third year, and sometimes master students as well. And depending on what stage of career they're in, and what they're looking to do, they definitely use this to put it on their resume, and not only to get some experience for themselves, but really to take that outside and show these companies and other firms, to show them how interested they are about aerospace engineering, or about flight aviation.
How exciting that a couple of students have been able to come back and directly get some internships. But beyond that, the broader picture is that you're contributing some really, really good students and candidates out there into industry for those that choose to pursue this as a career. That's really, really awesome. Let's talk about where these competitions take place. We've got a UK competition and then a US competition. Tell us about those locations.
Yeah, absolutely. Yeah, we host this event, like you said, twice a year. So one in the US and one in the UK. The US one is typically based out of Dayton University. So Dayton, as you know, is quite a special place in the US, given the fact that obviously with all the history it has in aviation, Dayton University invested in our sort of simulators, in these high fidelity Merlin simulators, a long time ago, and ever since they have been not kind enough to host these events in the US. Universities from around the world, from around the UK even, fly to US for some of these competitions. Even though there's a UK version, they've been quite keen to go into the US and compete with US universities. So we've had universities from Cincinnati, students from Cincinnati attend these events, from Mississippi. We've had from Colorado, so really around the country. And like I said, we've had international, outside of US, people competing in that event as well. In the UK, we typically, the event has moved around, so we're not really fixed on a particular location. However, for the past few years, it's been hosted at Swansea University. They've also been the most successful one, so they're retaining the trophy that you win after sort of winning. The students typically take a trophy back to their university. So Swansea has been quite successful with that regard. So in the UK, again, we keep it international, so it's not necessarily just for the home turf, where the event is being held. It is open internationally, so sometimes we've had US students fly to the UK to compete, and we have people from Europe coming over. So yeah, we keep both events quite international, but it just happens twice a year, two different venues.
Now, if somebody wants to check out these competitions, if they're part of a university organization and they say, man, this sounds pretty neat, where should they go? How can they integrate and get the information for this?
Yeah, great question. So of course, from our side, we market this globally, so people typically have heard about us. So whether you go on our website, there's brochures, but I would say the most important thing is every university has an aero society. Well, most universities at least do, and most aerospace societies will know of us. So we've always been, keeping in touch, making sure we can support students in different fronts. And of course, with such events, a lot of, universities already know about us. So if anyone is interested, all they have to do is either reach out to us or inquire to the Aero Society president, and they should be able to point them towards us.
That's it. It sounds like this is the place to be. This is fun. Gordon, tell us a little bit about the experience, the atmosphere of these competitions. Give us a little bit about what it's like to attend and to be there at these competitions.
Well, I think like most meetings of different groups in a new place, there's always that bit of apprehension and shyness. But we usually have a nice breakfast with donuts in the morning, coffee, get people warmed up, and then we go into the introductions, and then we crack on. It's like most things, there's a bit of ice to be broken, but once it gets going, once we see the individual teams, working through it, and just a slight explanation is that we have an auditorium where on the screen is the actual flight test in progress. So all the other team members can actually see another team's project being evaluated in real time. And, that's really exciting for them. So I think it's not like waiting in the doctor's surgery ready to go in. Everybody's involved from the very beginning, and it's a great experience. And the very end of it, when we all break up after the sort of awards, there's a sort of great camaraderie, and I'm sure emails and telephone numbers are exchanged, and so it's a really warm, exciting, and invigorating and learning experience.
Tell us a little bit about that awards ceremony and the prestige that these students get to experience as part of that.
Yeah, great question. So, of course, the purpose of this whole event, again, is going through that end-to-end journey. But like Gordon said at the start, there's icebreakers towards the sort of the middle of the event. You see a lot of networking between the students with the professors. So it's nice to kind of like get them, seeing them a little bit, more involved. And of course, by the end of the competition, everyone's like, okay, we want to see how we've done. We're eager to hear the test pilots give us some feedback. So, of course, the test pilots give the students individual feedbacks on how their design performed. And I think that is really valuable. But just to finish off the event, what we do, we've got a little sort of prize ceremony at the end where we give prizes to the first sort of the winning student that had the best sort of design in terms of how the performance of the flight. And then we typically give also prizes to the people that had the best presentation in terms of defending their designs and the idea and the methodology of why they came up with that design. And lastly, we also have a design for the most innovative design as well. Like you mentioned, Shawn, sometimes students like to go out there and be brave and design something, but then sometimes they just don't get it right in terms of the flight, or it's really hard to get it right. And with the time frame they've had, with the effort they've put in, we obviously do appreciate that they were trying to be a little bit bolder than to play it safer just to achieve. So we have sort of prizes, and we like to appreciate and give a round of applause to everyone for their efforts. But the idea of this whole event is it flies and how it flew, so how the design flew, and therefore the biggest honorable prize goes to the team that had the best design. And that team also gets a trophy where their name, sort of kind of like the university names, goes on the plaque, and they retain that trophy. It's a Harrier that basically travels between universities. So whichever university that wins the event gets to take this trophy away to their universities, and they hold it until sort of next year's event.
That is so exciting. That's got to be a point of pride for those students. It sounds like it's just really a great time overall. And of course, the ultimate reward is the intrinsic one of going through this It Flies Design Build Fly competition, because this is such a great end-to-end experience. Where do you see this going? How does the future look for the It Flies Design Build Fly competition?
Yeah, great question. So our goal is to keep doing what we've been doing for the past, it's been over 15, 20 years that we've been doing this. So we're not looking to change much. We want to keep it open. We want to make it accessible to everyone. So our goal is to enable more students and more universities and be able to participate at such events. For us, given the fact that it's, like you said, the spectrum of, it's the fact that it's quite end to end. You start, from the theory that you learn at university. You don't have to do anything new. Just the knowledge that you have from universities, from what your professors have told you. Most engineering courses typically have an aerospace design module. So it's just basically getting those data and popping them into the simulators and flying them effectively. So we don't want the students to go away thinking that, I've got a semester, I'm busy, I've got exams, there's too much to do. So our mission as a company is to make sure that these students don't feel that way, and all they have to do is show up, have fun, focus on the designs, be creative, and for us to expand on the success that it's had so far.
It sounds like it's just a great way for students to take what they're already doing, all that hard work, bring it right into this fun, practical competition. And we've mentioned fun. I think we should have a little bit of fun. We've done a lot of heavy lifting over here. I feel like we've been through a competition ourselves and won. You want to have a little fun right now? What do you think?
Yeah, absolutely.
3 fun questions right here. And I'll start with you, Amir. What's your favorite in-flight snack?
Probably peanuts that we're not allowed to have anymore, I think. But yeah, peanuts.
Right. Yeah. Yeah. No, you can't have that in the commercial aircraft anymore. But power packed, protein packed, and compact. So not doesn't count much against the useful load, which I like that. You and I can fly anytime. Gordon, tell us about what your favorite in-flight snack is.
Well, I was going to say peanuts as well, but
Hey, we're all
well,
outlaws
we
here.
call them in the UK packets of crisps. I think you call them chips, but crisps.
Yeah. All right. Totally fine.
Cheese
Good.
and onion.
Oh, solid.
Flavorful, flavorful. Anaid, do you want to hop in here? What's your
Chocolate.
Oh,
Chocolate.
I knew it. I knew it.
Any
Yes,
kind.
classy.
Just
Any
chocolate.
kind. Okay. Okay. Now we talk about these great designs, these interesting aircraft. What is your favorite type of aircraft, or what would be your dream aircraft to fly on or to fly yourself? Gordon, I'm going to start with you.
Well, my background is mainly in military airplanes and certainly smaller airline types. I've been lucky to fly a couple of big airplanes, but the one airplane I've never had a chance to fly for real would be the Boeing 747. That would be something I think that would be, because it's so iconic. That is something I've actually flown a simulator, which is pretty good. But yeah, I think to fly a real 747 would be something I would love to do.
Yeah, man, sign me up. I'm I'm buying a ticket, taking that ride. Now, Anaï, what would you have a favorite aircraft, or would there be one that you'd love to fly on?
Well, being a French person living in the UK, I guess I have to say the Concorde, but if it's
Nice.
not possible.
I love it with some chocolate. I love this. Now, Amir, what do you think? What's your
I
dream
actually have
aircraft?
two answers, I think. I would
Yeah,
love to
bring it.
fly the 787. About 10, 15 years ago, I spent about 2 years designing a long version of that aircraft that flies from the UK all the way to Australia. So I've spent a lot of time designing that, not in a simulator, unfortunately. I designed that on a piece of paper, or on a lot of papers, let's just say. So it was a lot of theory. So I would like to fly that just because of the amount of time I've spent on it. But if I want to be a little bit more adventurous, I don't know if this aircraft is in operation anymore, but the SR-71. I think it's retired, but if not, then yes, I would like to have a go.
Yeah, man, absolutely. Why wouldn't you? Love it. That's an engineering beauty right there. Now, we have two more questions. Annie, I'm coming to you first, right off the bat. Where's your dream destination? We've got the Concorde and plenty of chocolate. So where do we go? What's our...
Anywhere warm.
Okay.
Anywhere warm where, the Maldives. Just love
Oh,
the Maldives
yes.
before it disappears.
Yeah, you're right. It's a limited time only, possibly. Amir, come to me with your dream destination. We've got plenty of time. We've got all the resources we need. Where do we go?
I think I like to go to New Zealand. Yeah, New Zealand. I haven't been.
Yeah. Okay. Yeah, I'm going with you. Now, Gordon, what's your choice? What's your dream destination?
Well, it's not too far from home. In fact, Anne and I were talking earlier on about her husband is learning to fly, or going through his license thing, and he was learning to fly in Marseille. So close to Marseille is a beautiful airport in Nice, and it's built off the shoreline. And I think I've flown in there maybe a couple of dozen times on aeroplanes. And it has a very interesting curved approach to it. And you've got the whole Côte d'Azur, Nice, and you can go around the corner to see Monaco. And you land there. And we usually go and stay in a hotel called the Hotel Negresco, which is one of the best ones on the Via de Anglais. It's just a great place. But one thing is for sure, you have to find somebody else to pay for it, like your company, because it's a stinkingly expensive place. But yeah. It's close to home. My range now is about 2 or 3 hours. I don't want to fly any more than that.
You or me both, man. That trip on the 747 would be one of the shortest routes that they have. I have to say, because I'm not a long distance. I'm not a long haul guy.
No.
Now, here's our last one, and this one's a little bit of a thinker. If you could fly with anybody throughout time, if you could ride with them as a passenger and talk to them, interview them, or you could actually get in the flight deck and sit right or left seat with them, Gordon, who would that be?
I think it would have to be Sullenberg, the chap who landed in the Hudson, because he's an ex-military pilot and an airline pilot, and he did that amazing landing. So I think he'd be good company. And I think if anybody from the front cockpit said, "Is there anybody who knows to fly an airplane?" He's the guy you want to be flying with.
Yeah, no kidding. There's a lot of folks got some, chair flying sim time. from the house, I would fly with him any day of the week. Amir, coming up to you, who would you fly with?
Oh, I love this question. It needs a little bit more thinking, but I'm not going to go with pilots or anyone that knows how to fly. I'm going to go with an Xboxer. Yeah, Muhammad Ali, if I can pick, to have a chat with in the back.
Yeah, right on. Now that's going to be an entertaining chat right there. Somebody else at the controls. I love it right there. Now, okay, top right, Anai, what do you have? Who would be your dream individual to fly in an airplane with?
Well, because of the current situation and because he's going to be listening to that podcast, I have to say my husband. I've no other option.
Wonderfully done. Wonderfully done. Excellent. From nose wheel steering going the wrong way to designs that look brilliant on paper but didn't fly so well, every single moment in It Flies is a teaching moment. And that's exactly the point. What strikes me most about this competition is how it mirrors the real aerospace engineering process. The briefs, the test flights, the debriefs, the collaboration between engineers and test pilots, the iterations, the revisions, the moment when students realize their equations are now physical motion. This isn't just a competition, it's a gateway into how the industry actually works. If you're part of a university aerospace program, or if you know students who would benefit from this experience, head over to steantycip.com/events to learn more about It Flies. We'll put the links down in the show notes. The competition runs twice a year, once in the US at Dayton University and once in the UK, and it's open to international teams. That trophy with the university plaques, it could be headed to your campus. Before we close up shop, please take a moment to subscribe to the Future in Flight podcast and leave us a review. Your support helps us bring you more conversations about innovation in aerospace education. And remember, whether you're designing a business jet or a 6th-generation fighter, the best designs come from iteration, collaboration, and the courage to put your ideas to the test. Blue skies, smart designs, and always remember, it's not about getting it perfect the first time. It's about learning from every flight. We'll see you out there and up there.